than the size of buff. So we've talked about size of before, and size of returns the number of bytes that variable is allocated into memory, and it's 20 hex. And counter right now is 0. So 0 is less than 20 hex. So we're going to go in and execute that hex statement. So inside this if statement, this code is going to run. And what this does is it's going to assign whatever value is in CH into the buffer array at index CTR, which is currently 0. So this now takes that value 68 and puts it up here. 0 x 68. Okay. And then the last thing it will do is increment CTR, the plus plus. So now, so after it's made the assignment, it will then use that plus plus operator. So CTR now becomes 1. So it was 0, plus plus makes it 1. And then it says, so it exits that, and it says, if CH is equal to carriage return /R, then go and run this code. Well, it's not, so we're not going to run any of that code. It exits that if, and it comes back around and comes to this statement again. When we did the serial read, I failed to mention this, when we did the serial read, it removed one character from the serial buffer, and now the serial buffer has 2 characters in it. The serial buffer I don't have on the board here. The serial buffer is it's part of the library. I'm not showing what's going on in that code. That's additional code that we, at this point, don't need to look at to be able to utilize it. But it's just going on in the background. So we come back around, and serial available is now equal to 2. And 2 is greater than 0. So we go into this code, and we read again. And now when we read, we get 69. 0x69. And we check to see if counter is less than 20 hex. Counter is currently 1. 1 is less than 20 hex. So we go into this line of code again, and it assigns the current value of CH to buff at position CTR, which is 1. So put 69 here. Exits that if statement, comes in here and checks, is CH equal to a carriage return? It is not, it's 69, so it exits and comes back around. Serial available now returns 1. 1 is greater than 0, and so it goes in to the if statement. It does the read again. The next character we read is 0D, carriage return. Okay, and we exit that if statement. Then it says if carriage return, or if character is equal to character return, if CH is equal to character return, carriage return, go into that if statement. CH is 0D. 0D is the carriage return character. So now we enter this code. Oh, we forgot the increment counter. Counter should be 2. The increment counter from that plus plus. So we come in here and we store in the buffer index location CTR minus 1. So CTR is currently 2. 2 minus 1 is 1. So at location 1, I think I forgot to increment it twice. Yeah, I forgot to increment it twice. It should be 3 right now. So 3 minus 1 is 2. So at location 2, we're going to store the value 0. So this is 0. 0x 0, 0. Or is just 0. We set CTR back to 0. And then we print command, colon, space. So this gets printed out. So we'll see up on our serial terminal. Colon and a space, little space here. And it says if buffer 0, if buffer position 0 is not equal to 0, then print whatever's in buffer. If it is 0, just print a new line character. And this is due to a bug that I think has been fixed. So we could have just, if the bug has been fixed, we could have just print out whatever buffer is. But there used to be a bug that if there was nothing in buffer, it would crash the board. But I think that's been fixed. So this code, I think, is kind of overtly complicated if that bug has been fixed. We might check it later to see. But all this is doing is checking to see if position 0 is not 0. So position 0 is not 0, it's 68. So what it will do is it will print the contents of buffer. So what this print routine does is it's a loop, and it's going to go through. It's going to start at location 0 and print 68, which is going to show up as the letter H. Then it's going to look at the next one and see that it's 69, which is the letter I, so it's going to print the letter I. And then it's going to look at the next position, and it's going to see that it's 0, so it's going to stop, and it's going to return.